Good morning, everyone. What are you guys doing today? Good. Okay, so we are in chapter 2, and I believe we will be able to finish chapter 2 today. So I think our first exam will be based on chapter 1 and chapter 2. Okay. Tomorrow we are going to, I think today also, we may start chapter 3, and tomorrow definitely we are going to do chapter 3, but that will not be in the exam. Chapter 3, 4, 5 will be our second exam. And the final exam will be cumulative from chapter 1 to chapter 5. We had only 5 classes. What to review? But if you have any specific question, I'll go over those questions. And yeah, like we had only 5 classes, right? Today is 6th class. Day after tomorrow. Thursday. And there is no review sheet because actually I don't know what to put in the review sheet besides the questions. So instead of putting all the questions, I told you just to study all the green examples. For example, here, the example is written in green. So in your lecture notes on Brightspace, look for all the green examples. Study those and you'll be fine. I'll just give questions from those green examples by changing variables, numbers, those things. But exams and questions. Okay? I didn't make the exam yet. But in the final exam, we have around 40 questions, 2 hours. And we have 2.5 hours, 2 hours, 30 minutes. Expect to see a lot. Um, Technically, we shouldn't do that. I'm supposed to give you only 1 hour exam, but I feel like after the exam, you'll be so stressed, you'll not able to concentrate on the materials. I can teach no problem, but I don't think you'll be able to digest anything. So that's why we are in good pace. Like we already finished chapter 1, today we're going to finish chapter 2, and you have only 3, 4, 5. 5 has only 2 sections. So I think we'll be able to finish everything before our final exam. So let's see this exam. I'm going to make like final exam. The format, everything will be final exam, multiple choice. I may not give you the multiple choices, but it will be like multiple choice. So you get either full credit or 0 credit. And then there will be some partial credit questions. But most of them are multiple choice without multiple choices. So no partial credit for the most of the, like 2/3 of the exam will be no partial credit and 1/3 will be partial credit. And it will be the entire class time. So I'll give you I'm planning to give you every green question, most of the green questions. Okay, that's my plan. And see how you do in this exam. And then probably if we don't have enough time, we can shorten our next exam to 1 hour and then do materials the other 1.5 hours. Okay, any other question? No question? Okay, so the last thing we did in our last class was doing one example with all the information. So refresh your memory to find x-intercept of the rationale. First, you need to modify your function, means simplify it if possible. Once you simplify, only take the numerator set equals to 0. That's going to give you x-intercept. The same simplified version, if you take the denominator set equals to 0, that's going to give you vertical asymptote. So numerator gives you x-intercept, denominator gives you vertical asymptote. Now for horizontal asymptote, you can take the original version or the simplified version, it doesn't matter. You look at the highest degree on the numerator and highest degree on the denominator. And then if they are same, their coefficients are the horizontal asymptote. So it's a horizontal asymptote. So you're supposed to write y equals a number. So y equals the coefficient if the powers are same. But if the denominator is big, then it's always 0. Y equals 0. And if the numerator is big, then there is no asymptote because the line is going on forever and ever. And then we have domain. Y-intercept also, you can take the original function or the modified version. You're going to get the same result. We take the function, set all the x equals to 0, then whatever constant remains, that's our y-intercept. For domain, you must take the original function. You cannot take the modified version. So among all 1, 2, 3, 4, 5 things, the only thing that use the original function is the domain. So to get the domain, we look at the denominator. What makes the denominator 0? We cannot have those numbers from our number line. So we omit those numbers from the number line, and then the entire number line is in our domain besides those. If it's rational, and if you have radical on the denominator, then you also have two things to consider: what makes the denominator 0 and what makes the radical negative. You have to omit those numbers from the number line, and the rest are in our domain. Okay. So we did one example. Let's do another example today. So before you start modifying, you should always find domain if they ask you to find domain. So we are going to start by domain. Which domain? For domain, denominator can't be 0. So we have 12x squared plus 6x. This thing cannot be 0. And then we need to solve for x. Which x values makes this thing equals 0? So how do you solve it? How do you start? Any idea? Factor GCF. Great. What do you see GCF here? 6x. We factor out 6x. Then what is left? 2x plus 1. And I didn't do anything. Come on. And then what do we do with those factors? Set not equals to 0 because we don't want them to be 0. So 6x cannot be 0. So 6x, we get 2x plus 1. So 6x cannot be 0, or 2x plus 1 cannot be 0. Then x cannot be what number? 0. And here x cannot be what number? -1/2. That means in the number line, from all these numbers from -infinity to +infinity, we can take the entire number line. We just cannot take two numbers. What number is supposed to go first? -1/2, and then 0. So our first interval is here. How do we write the first interval? (1/2). And what should be the boundary? Parentheses, because we cannot use (-1/2). Anytime we cannot use a number or there is no y value exist, then we put parentheses for that number. And then we have our second interval. -1/2 to 0. And then the last one is from 0 to infinity. So basically the entire number line except these two numbers. So we are done with domain. And now for everything else, you can use the modified version. Let's start with particle asymptote. Before even doing particle asymptote, first you have to simplify. So let's simplify this expression. We have y equals 10 minus 5x divided by 12x squared plus 6x. Denominator, we already know we have a GCF 6x, and we left it 2x plus 1. How about the numerator? 5. And then what is left? 2 minus x. Can you cancel anything? No. Okay, so particle asymptote. For particle asymptote, simplified FIED. Simplified denominator equals to 0. Even though we could not simplify, it doesn't matter. Whatever denominator we have, we set them equals to 0. That tells us 6x0 means x0. 2x plus 1, 0 means x is -1/2. So we have two vertical asymptotes. Means our graph breaks into three pieces twice. Horizontal asymptote. I didn't do anything. Use 3 rules. So y equals. If we take, since we could not cancel anything, so let's observe the original one. We have -5x, the highest degree, and 12x squared, the highest degree on the denominator. Which one is bigger, numerator or denominator? So for when denominator is bigger, what's the horizontal asymptote? No, that y equals 0. See, denominator is bigger. So when our x become bigger and bigger, this number goes towards 0. For example, here, if x is, come on, I didn't do anything. What's wrong with this? If x is, let's say 1, then we have -5/12. Then when x is 10, then we have -50 over a big number, 120. So the bigger the denominator, the smaller the fraction becomes. So the fraction becomes smaller and smaller and smaller and smaller. So eventually it will go toward y equals 0 line. We divide the highest degree on the numerator by highest degree on the denominator, and we ignore everything else. So denominator big is always 0. When the numerator is big, then there is nothing we can do because the line is going on forever. X-intercept. How do you find x-intercept? Simplified numerator equals 0. You can ignore everything else, just look at the numerator. So we have 5, 2 minus x equals 0. Divide both sides by 5. That gives us 2 minus x equals 0. If you add x to both sides, that gives us x equals 2. And lastly, the easy one, y-intercept. Set all x equals 0. So y equals 10 minus 5 times 0. And then we have, let me erase this. We have 0 plus 0. So we have 10 over 0. If I give you $10 and tell you to divide $10 into 0 pieces, can you do that? It's impossible. So what's the word we use in math for impossible? Undefined, doesn't exist. So we have an interesting graph. We have 3 pieces in the graph. We have x-intercept at 2, but there is the y-intercept. Did I make a mistake? No. 0 in the denominator. So y-intercept is impossible. How can we have a graph that y-intercept doesn't have? Oh, that's because x equals 0 is a vertical asymptote. Come on. We didn't have to do anything because from here, you can already see x equals to 0. When we have y-intercept, our x must be 0, right? So when x is 0, the graph doesn't exist. So there is no y-intercept. Now, using all this information, let's try drawing a graph. Why this is so small? So we have x-axis, y-axis, and we have -1, half, and 0. So when x is 0, there is a vertical asymptote. And when we have -1 half, there is also a vertical asymptote. 2 vertical asymptote, x equals to 2, 1, 2 is our x-intercept. There is, and there is a horizontal asymptote at y equals 0. Doesn't it look weird? When y is 0, we have a horizontal asymptote because denominator is bigger. And then x equals 2, x equals 2 is a horizontal, x equals 2 is our x-intercept. X equals 2, right? 2, add x to both sides, so we have x equals 2. Do you have any other information? 0, -1 half. 0, -1 half. Did I make mistake anywhere? It's positive, so we get a negative. This is positive 2. Okay, x equals 2. There is a trick, bro. This has power 1, this factor has power 1. So on the vertical asymptote, we have one side infinity, one side negative infinity. If we have even power on the vertical asymptote, then we have both infinity positive or both negative infinity. Since we don't have even power, we have only odd powers on our vertical asymptote. So one end will go upward, the other end will go downward. Now the question is, which one will go which way? So let's find a number on the left side of -1/2 and see what's the y value. So when x is -1, 10 times 5 times -1, and then 12 minus 6. So we have 15 divided by 6. It's positive somewhere here. That means this side will go up. Since this side go up, that means definitely this side will go down. Because -1/2 has multiplicity 1 for vertical asymptote. That is what I'm looking into. For horizontal asymptote, we can cross the vertical. We can cross it. The vertical asymptote we cannot cross. So let's see when x is 1, how much is the y? That will give us some idea. So when x is 1, we have 5 times 1, and we have 6 plus 1. So here 10 minus 5 is 5 over 18. It's smaller than 1, but it's positive. So it's somewhere here. Okay. Let's see when x is 0.1. Then what happens? So we have 10 minus 5 times 0.1, and then 12 times 0.1 square plus 6 times 0.1. 5 times 0.1 is 0.5. So 10 minus 0.5, 9.5, right? 10 minus half, 9.5. And denominator is positive. So we have a positive here. Okay, so I believe, no, it doesn't make sense. 12x squared. It's an ugly one. 1, 2, 3. So, see, we cannot cross the x-axis, because if you do, then we're supposed to have an x-intercept. But we have only one x-intercept here. You know what? I'm so tired. Let me just look at our friend and see what it tells us. With the numerator, please. 10 minus 5x, right? 5x. And denominator, 12x squared plus 6x. Okay. It's crossing the x-axis with x equals 2. So we do have x-intercept at 2. On this side, it doesn't cross because we have a horizontal asymptote. So it cannot cross on one side. But what is happening in the middle? There is no portion in the middle. There is no portion in the middle on the upper side. How about the bottom side? What is supposed to have a middle portion? Oh, middle portion is here. Ah, yeah. That's why it doesn't cross the x-axis because it's on the bottom. So I did math wrong. We had 10 minus, oh, it's negative, so it's plus and the bottom is negative. So yep, the middle portion. Okay, so this is what is happening here. But good news, in the exam, we don't have to draw the graph. Okay, so middle portion doesn't cross the x-axis, so it has to come back on both direction toward negative infinity. Here, see, remember I said this 6x has multiplicity 1, so on the vertical asymptote, one side will go negative infinity, the other side will go positive infinity. So if this side is going negative infinity, this side must go positive infinity. And if you want to use the x-intercept, that means we have to cross it here. Horizontal asymptote is weak, we can cross it, but the vertical asymptote is very strong, we can never cross vertical asymptote. I don't know why it's weak, but horizontal asymptote itself is weak. We can cross it. But I thought we can only cross in the middle, but now I see no. We can cross also on the side. So the right portion, we can cross, but for the left and the middle, we cannot cross. So it has some strength, but for example, when we have a garden, we put fence around that, right? Those fences are very strong or weak. Of course, weak, right? That's why animals can jump in. But if you put a wall, can they cross the wall? Definitely not, because wall is strong. So vertical asymptote is like wall, we can never cross. But horizontal asymptote is like fence around the garden. It's weak, it's there so that we don't have to, people don't cross, but sometimes people are smart, animals are smarter, so they can cross. So horizontal asymptote is fence, vertical asymptote is a brick wall. Okay, so with this, we are done with finding all this information. But in the exam, in the final exam, usually they give you the graph and ask you to identify all the information. Okay, one interesting question. Let me erase the answer. We have a rational, and they are telling us we have a vertical asymptote at x equals 2.5 and 3.3. Unfortunately, they did not give us the equation of the rational. They want us to find the equation of the rational, especially for the denominator. Numerator is x, we don't have to worry about that. But in the denominator, they give us two variables. So if you know your vertical asymptote, can we find the denominator? Of course we can. The question is how. How can we find the denominator using vertical asymptotes? Any idea? Go ahead. But you have two variables, B and C. So x cannot be 2.5 and x cannot be 3.3. But since their vertical asymptote, so our equation is x equals 2.5, x equals 3.3, because they are vertical asymptote. For domain, we put not equal, because for domain we cannot use them. But vertical asymptote is which number gives you problem. So it's equal sign. X equals 2.5 gives us problem. X equals 3.3 gives us problem. The vertical asymptote is asking for the problem. Domain is asking erase the problem. That's why for domain we put not equal. For vertical asymptote we put the equal sign. Good start, but what do you do from then? From there? B over 2a is for quadratic. This is not a quadratic. This is rational. But your first step is great. And the hint is there. What can you do so that x equals 2.5 and x equals 3.3 will turn into x squared plus bx plus c? We can do that, but the problem is you have two variables, b and c. You have one variable, definitely. But for two variables, how? That's the idea, factor it, but what to factor? How to factor? If you know x minus x is 2.5, then what factor you get from there? Remember, particle asymptote is denominator equals to 0, right? So do you see 0 in x equals 2.5? Vertical asymptote is denominator equals to 0. So we want to see 0 on one side. What can you do so that instead of 2.5, you can see 0 on one side? Subtract 2.5. So x minus 2.5 equals 0. And how about 3.3? Same thing. X minus 3.3 equals 0. So basically, we are going backward from what we did in last two examples. In last two examples, we took the denominator, set it equals to 0. We factored them. We set each factor equals to 0. We solve for x. Here, they give you the x. So we found the factor. And then what do we do with these factors? If you compare this with this. So then started with this, x equals something, x equals something. So we went to this step, the factor equals 0, factor equals 0. And what did we do before that? Multiply the factor. We are going backward from the last example. So x minus 2.5 times x minus 3.3 equals 0. Now we distribute. We have x squared minus 3.3x minus 2.5x, and then whatever we have plus 2.5 times 3.3. 5.8. So we have like terms here. So we have x squared minus 5, 3 is 8, 3 is 5. Or in the middle, 5.8x. But how about the multiplication? 8.25 plus 8.25. So what is our b? Negative 5.8. And what is our c? 8.25. So we did completely opposite of what we did to find vertical asymptote. And we can check the answer because I have the answer here. Yep, the answer is correct. Who is lost? Anyone? I'm here to help you guys. If you did not understand, don't feel shy. Ask me. I'll re-explain everything. Anyone? No one. Then we have one more example. Oh, it's easy. It's only asking for horizontal asymptotes. And remember, all these green examples, you have to study for the exam. Because I'm planning to give almost all the green examples in the exam. Oh, I'm going to take that tables. Oh. Rizia, oh, Hector G, yeah, Marco, yeah, Joanna, yeah, Dayanara, still not here. Gabriela M, Neva, Hector B, absent. Faria, absent. Arif, here. Movina, here. Gabriela D, here. Mia, here. Diego, here. Tristan, here. Pragjot, here. Rachel, here. Julia, absent. Ritika, absent. Idalia, absent. Fabia, yes. Angelo, yes. Isabella, yes. Steven, yes. Brian, yes. And Shihan, absent. Kimberly, yeah. So who is ready? Hector, go ahead. What is your first step? What is your first step? No. Coefficient for your highest degree. So 9 and 27, they don't have any variable. So ignore them. I mean, you cannot ignore 27. So before you even go for horizontal asymptote, you see the numerator is factored form. So distribute to see your numbers. We have 27 times 5 plus 27 times 4x. And the denominator is, come on, 9 minus 0.08x. So what is the variable on the numerator? How much? 18x. 9 minus 0.08x. So what is our variable? What's wrong with this? What is the variable on the numerator? I said variable, not number. X. With what degree? 1. What's the variable on the denominator? With what degree? Are they same, the power? So when we have the same power, what is our horizontal asymptote? Y equals A over B. So what is our A here? 108, the number in front of it, the numerator variable. And what's the b here? Negative 0.08. So you have to divide and see what's the number. $1,350. 1350. There is no point or anything. Wow, it's a whole number. That's it. That's our horizontal asymptote. You look at the highest degree on the numerator, highest degree on the denominator. If they are same, you look at their coefficients. That's why we have to distribute the 27, because on the numerator, it's not only 4x, it's 27 times 4x. And if the denominator is bigger, then it's always y equals 0. If your numerator is bigger, the line going on forever, so there is no horizontal asymptote. Any question? Okay, do you have more? No, we're done with section 2.6 or something, whatever. And now this is our last section for chapter 2, 2.7. And in this section, we are going to do inequalities. So the difference between solving equations versus solving inequalities is that anytime we solve equations, we get x equals a limited number of numbers, like x equals 1, x equals 0, x equals that. So we have a few numbers that we have for x equals something, or when we solve, we get x-intercepts. Okay, so that's why they're limited, because we are crossing the x-axis only limited amount of time. On the other hand, when we solve inequalities, we look at a portion of the graph. Which portion of the graph is positive? Which portion of the graph is negative? So we don't have one number or two numbers. We have a set of numbers, an interval of numbers. So it's always an interval notation. Anytime you solve inequality, it's always a bunch of numbers, or always we have to write them in interval notation. Now we have 4 types of inequalities. This symbol, we call it greater than. This is greater than or equal. This is called less than, and this is less than or equal. So whichever side has the mouth, that mouth is bigger, and whichever side has the tail of the inequality, that's smaller. So if we have x here, and then the mouth is toward the x, and then we have 5, it means x is bigger than 5, which we are taking all the numbers that is bigger than 5. But if we have x is here and the mouth is toward 5, now 5 is the biggest number. So we have all the number that is smaller than 5. So x is smaller than 5. Now for inequality, if you have an equal sign, that means if you don't have an equal sign, we're supposed to have parentheses here, because x equals 5 is not in the solution. But if we have, let's say, bigger than or equal 5, then because of the inequality, now x equals 5 is inside our solution. So we're supposed to have a bracket for 5. Just like the thing we did before. If you can use the number, then it's bracket. If you cannot use the number, it's parentheses. So anytime you see something bigger than 0, basically it means we are looking for positive y values. If you have bigger than or equal 0, it means you're looking for when y is positive or when y is 0. So you have 2 choices, 0 and positive. When we have less than 0, anything less than 0 is negative. So all the negative portion of the graph we are looking for. And less than or equal 0, it means either y is negative or y is 0. So the equation gives us the y value. We look at the x value and we see the y value. Which y values are positive, which y values are negative. And depending on our inequality, we take the positive y values or negative y values. And now for the ending, if you have infinity and no equal sign, then it's parentheses. But if you have equal sign in the inequality, it's bracket. So once you know these rules, we can easily find all the things. You didn't have to write down all the information. I wrote them down so that when you do the math, you can read it again and again to understand the concept. What I'm going to do is I'm going to do a few examples based on all the rules I mentioned. So when we solve the inequality, first thing we do is we find x-intercept because we want to see when we are crossing x-axis. So step one, find the x-intercept. To find the x-intercept, we take each variable, each factor, we set them equal 0, we solve for x. That's going to tell us our x-intercepts. Now, based on the x-intercept, then we're going to find positive y value or negative y value. So step one. Find x-intercept. So for example here, if you know you have these x-intercepts, then we are going to find our positive or negative y value. So we pick, we see if this is positive, this is negative, this is positive, this is negative. So whatever we are looking for, we take this in our solution. So less than 0 means which part we are looking for? Positive or negative? So less than 0 means what? Positive or negative? Negative. So our solution will have this and this. So that's why we need the x-intercept. We see where we are crossing the x-axis, and then we find the y's. Which y positive, which y negative. And then we look at what they want us to find. Positive y or negative y. So here we are looking for negative y because it's less than 0. If they ask for positive y, our answer would have been the top portions of the graph. Now, how do you find all those y? That's the trick I'm going to show you. So find x-intercept. So we have x minus 5 to the 4 power equals 0, x plus 1 to the 3 power 0. That's how we find x-intercept, right? We set y0, solve for x. So that gives us x minus 5, 0, and x plus 1, 0. So what is our first x-intercept? X equals 5 and x equals negative 1. Now x equals 5 has multiplicity what? 4. So it's an even power, right? Even. And x equals negative 1 has multiplicity what? 3. So it's odd. So why do we care? Well, if you want to use multiplicity, you have to do math. But if you don't want to use multiplicity, then you have to find y value in each interval. So we take our x values and we plug them in the equation. Sorry, not in the equation, the number line. We have two y values, 5 and negative 1. And then we have on the left negative infinity, on the right positive infinity. And if you want, never mind, it will make it confusing. Okay, so we have to find the y values in each interval. And then we have to see which y value is negative. So for the first one, we really have to find it. Pick any x value here so that you can find the y value. What number we have less than negative 1? So let's start with negative 2. When x is negative 2, inside. We picked x equals negative 2. We want to find the y value. So we substitute here. Negative 2 minus 5 to the 4 and then -2 plus 1 cube. So this thing is positive, right? Anytime you multiply -4 times, it's automatically positive. So the first portion is positive, and this one is -1 cube. So we have a positive times a negative. What's the y value we have here? Negative. So this y value is negative. And then you have choices. You can keep finding y values by picking points from each interval, or you don't have to. Why you don't have to? Because we are going to use the multiplicity tree. -1 has multiplicity add. If your x-intercept has multiplicity add, the sign on the left will be different than the sign on the right. You can verify that by putting a number from here. For example, x equals 0. Substitute x equals 0, get the y value. You'll see the result will be positive. But I know that without even doing any math. How? Because the multiplicity is telling me that. For even multiplicity, for odd multiplicity, remember we cross the x-axis. So if this is negative, definitely we are crossing through -1. So y value must be positive here. For odd multiplicity, we cross. For even multiplicity, remember we cannot cross. We just touch and then we turn back. Do you remember the multiplicity trick which I told you last class, right? If it's even multiplicity, we just touch the x-axis and then we come back. For odd multiplicity, we cross the x-axis. So if our y value is negative here, we have to cross through -1. So definitely my next y value have to be, all the y values must be positive. So this is my positive y value. Now x equals 5 has multiplicity even. That means once we come back, we cannot cross. We need to touch and then come back. Now we cannot change the sign. So this is positive. So if I draw the graph will be something like this, -1 and 5. So we are crossing, and then we are touching, and then we are going back. We start with negative portion, and then we cross the x-axis through -1 because these are x-intercepts. And then when we come back here, we cannot cross, so we are turning back. So this is positive, this is positive. But what you're looking for? Oh, so you always test for that first. The first one. You start with first one, and then the rest just follow multiplicity. And then when following the multiplicities of those x portions, how do you know this? Or you just let's start from here. We pick your x value, we found our y is negative. Right? So all the y values are negative here. But this is our x-intercept. This x-intercept has multiplicity add. Add means we have to cross it. So from the even, we are crossing here. So what's the y value here? Positive, because this is negative. It's not positive. And then we have to use this x-intercept, right? But what's the multiplicity for our next x-intercept? Even. For even, we cannot cross. So if you cannot cross, you're just coming here, touching it, and then you're way back. So what's the y value we have? I don't know. We always start from the left. Find the y value here. So it's always whatever is to the left. So after that, next part we're looking at the left of 5. We are looking at the x-intercept. So this is my y value, negative. This is my x-intercept. Remember, x-intercept means you're crossing or you're touching. Either one of these two. So from all this negative sign, we have -1 here. We have to cross because it's odd multiplicity. So we are crossing here from left to the right.
And it even works in both ways too. If you figure the middle one out, then you know to the left has to be
exactly. You can start with anything, but if you start with the left, you're just going through the flow. So this is negative, right? And you're crossing through -1. Look at the graph. You know this is negative, right? This is negative, you know. But we have to use this -1 x-intercept. This is I multiplicity, so we have to cross it. So you're crossing. And then we are going on and on and on. We don't know how long we can go on, but we have to come back here. Because these are our next x-intercept. So it doesn't matter how far you go, eventually we have to come back to 5. Now when x is 5, you have two choices. You cross it or you don't cross it. You cross it, if 5 has odd multiplicity. You don't cross it, it's even multiplicity. So look at 5. X minus 5 has power 4. That means x equals 5 has even multiplicity.
What about when you get to that part after 5, which
That's it. It's going on forever and ever and ever. If we don't have any more x-intercept to come back. You have to come back if you have an x-intercept. You don't come back if you don't have an x-intercept. That's one choice, okay? The shortest method. The longest method says pick one x-value from each interval, substitute into the function to get the y, and then see the result.
Are we considered in a multiplication?
Of course. So what are you looking for? What does it mean? Less than 0. Positive or negative? Negative. Now we are looking for negative y value. Do we have any equal sign in our inequality? No. So what should be the boundary? Parentheses. Now we look at our interval. Which intervals are negative? That's it, only one interval. So solution here is only the first interval. Negative infinity to -1. Infinity always gets parentheses. And since we don't have the equal sign in the inequality, this also have parentheses. So basically they're asking, in this equation, which portion of the graph is lying below the x-axis? And see, this is the part lying below the x-axis. Okay. Any question? Is there anybody who is lost? So remember, two methods. This method is the shortest method. You just pick one interval and go with the flow based on the multiplicity. If you did not understand this, then your choice is take x value from each interval, substitute here, just like I did the first one, and then look for the sign. What sign you have?
so it's illustrated using the
Yep. If you have less than equal sign, then you go from -1 to 5. Because -1, 5, infinity, they all will give you positive 0.01. But it's only the greater than 0, then 5 doesn't give you greater than 0. 5 gives you equal 0. So you have one portion here, another portion here. And you omit the 5. Okay, so I have 3 questions. Let's do one, and then you can do the 2 together, 2 by yourself. So let me show you. I hate this review. Okay, let's do this together, and then you have 2 examples to do. So we have 2x to the 5 less than or equal 18x cubed. One of the requirements to solve inequality is that you have to see 0 on one side. Do you see 0 on one side? So what is our first step? Move the 18x cubed to the left so that it becomes 0. So we subtract 18x cubed from both sides. So we have 2x to the 5 minus 18x cubed less than or equal 0. And then we look for what? X-intercepts. So 2x to the 5 minus 18x cubed, or maybe we can do factoring first and then find the x-intercept. That will be easier. Let's factor first. Can we factor out anything from here? 2 and how many x's? 3. What is left? Minus 9. Can we factor this more? What do you get? X plus 3, x minus 3. And now this is the complete factored form. So we are going to find x-intercept from here. X-intercept. 2x cubed equals 0. That tells us x is 0. And what's the multiplicity? 3. Means add. The next one is x plus 3, set it equals to 0. X equals, with multiplicity, means the power on the factor, 1. So this is also add. And then the last one, x minus 3, 0. That gives us x equals 3. And what's the multiplicity? 1. So this is also add. So you have 3 x-intercepts, and we are going to cross all 3 times. Add means you're going to cross it. So let's put them on the number line or in the graph. Negative infinity, positive infinity, and we are crossing once, twice, 3 times. What's the first x-intercept? Negative 3. Next one, 0. The last one, positive 3. And we are going to cross all 3 times. So let's just find one of them. The first one. Take any x value smaller than negative 3, negative 4. And then we can substitute here or in the original one to look for the sign. Either one of them is fine. Let me use the factored one because it is simpler. We have 2 times negative 4 cubed, negative 4 plus 3, negative 4 minus 3. We don't care about the number, we care about the sign. So if we have, negative 4 cubed, what sign you get from here? Negative. Negative 4, positive 3. Negative, so you're multiplying another negative. Negative 4, negative 3, another negative. If you multiply 3 negatives, what's the result? Negative. So without doing even any hard work, we already know our first interval is negative. And now life is set. It's easy. We cannot use negative 3 because that's x-intercept. We cannot use x-intercept.
Greater than, less than, or equal.
When x is negative 3, 0.
But that's okay, because less than or equal.
Equal to 0, but we also need to know what is less than 0.
Yeah.
So that's going to pick a number between the x-intercepts. Wow. Okay, so our learning set. Now we don't have to worry about anything else. We are just going to keep changing our numbers. Why? Because -3 has at multiplicity, we have to cross. 0 has at multiplicity, we have to cross. 5 has 3 has at multiplicity, we have to cross. So if this portion is negative and we're crossing the -3, what should be the next portion? Positive y. And if this is positive y and you have to cross the x-axis, what's the next y? Negative. And now you have another x-intercept you have to cross. So positive. See? We don't have to worry about finding each interval. Just keep crossing. How do you determine sign? This is the math we did for one portion. So do only one portion and the rest will follow.
So what if it's like even?
See the last example we had even. X equals 5 has even multiplicity. So x equals 5 we could not cross. Okay. So before 5 we had positive. After 5 we also have a positive. We cannot cross for even. Even doesn't cross, so sign doesn't change. And we had to cross. Okay. So sign will change. Okay, so now let's see what they're looking for. Here. What they're asking us to find, which portion? -y or equal 0. So we have equal sign. What should be the boundary? Bracket. So which portion here we have negative? The first portion, including -3, because that's going to give us the y value equals 0. And then the middle, including both ends. Because when x is 0, y is 0. When x is 3, y is 0. So they are looking for y0 and -y. So what is our solution? How do you write the solution? -∞ to bracket 3, bracket 0, and 3 brackets. The infinity is here because we don't know what's the infinity symbol. This is included, so we have a bracket. 0 is also included, so we have bracket. 3 is also included, so we have a bracket. And guess what? In the final exam, you always have one inequality. Either they'll give you the factored form or they'll give you standard version. You're going to factor it and then find all this information. Okay. Any question? Nobody has any question? Because from 3 to infinity is positive y. But what they want us to find less than 0 is -y. Okay, great. Now enjoy doing these two. Can you see them? Are they too small? They're okay? So enjoy doing them and I'll be back. Do I have more? No, these two. So after doing these two, we can take a break. But not before, after doing these two. And also you can check your work with your neighbors. So you can have some sense whether you're correct or not. So who is ready for C? Volunteer for C. Go ahead, Marco.
The, okay, the first question that says 0.
Mm-hmm. 3x to the 5 plus 12 x cubed minus 12 x to the 4. Mm-hmm. The orders are wrong, so let me put the order in correct version so you can factor easily. Actually, let me do it in the next slide. 3x to the 5 minus 12x to the 4 plus 12x cubed. If factored out, 3x to the how much? Cube. Still left to it? Mm-hmm. Mm-hmm.
X minus 2, x minus 2.
X minus 2, x minus 2. So basically you have square. X minus 2 squared. Great. From here, what was the next step?
The next step was then to set up
No, you need to find the x-intercept.
0, 0.
So 3x cubed 0, that gives us x is 0. Multiplicity is add. Minus 2 squared 0. So x minus 2, 0. X equals 2 with multiplicity. Even. Great. And then the number line. Negative infinity, positive infinity. We are crossing twice. What's the first one?
The first one is going to be 0.
Mm-hmm.
The next
Mm-hmm. So test. Mm-hmm. V times negative 1 cube, 1 minus 2, negative 1 minus 2 square. So this is negative because it's a cubic function. And this is positive because this is square. So when you multiply them, the result is? But you're looking for the y value. Which y? Positive or negative? Negative y. And then what you're looking for? Positive. Only positive, no 0. No, this is negative. Then this must be positive. And this also positive because 2 has even multiplicity. Now, when x is 2 or y is 0, right? X is 2, y is 0. But are they looking for 0 y? They are looking for only positive y. So we have to omit that 2 from here to here. We can take everything, but we cannot take 2 because 2 gives us 0. We are not looking for 0. So what is our solution? Parentheses 0, 2 parentheses. Infinity. We cannot because when it's 2 or y value is 0. But they're not asking for 0 y. They're asking for specifically positive y. So that's why you have to omit that 2 from the number line and take everything else. Man, what's wrong with this projector? It's not my computer, I hope. Okay, any question? So remember, this will be in the final exam. Either something easier or something trickier. Okay, next volunteer. Ah. Factoring. So it looks like quadratic. X squared minus 9, x squared minus 1. So we split x to the 4 into two pieces, x squared and x squared. And we split 9 into two pieces so that when you multiply, they become positive 9, and when you add, they become negative 10. X-intercept. So x squared minus 90. But can you factor this more? X plus 3, x minus 3. That gives us x is negative 3 and x is positive 3. X squared minus 1, 0. So we have plus 1 minus 1. That gives us x is negative 1 and x is positive 1. And how about their multiplicity? All of them, they have what multiplicity? Add. Add multiplicity. So we cross x-axis through THROEGH through all the x-intercepts. So there is no turning back. You have to keep going on through the x-intercepts. So number 9. Negative infinity, positive infinity. Wow, we have 4. What's the first one? Negative 3. Negative 1. 1, 3. So let's test the first one. X equals what? Negative 4. So the y value. We have negative 4 square minus 9 times negative 4 square minus 1. I'm using this one. So negative 4 square, is it bigger than negative 9 or smaller than negative 9? Bigger. So this is positive. Negative 4 square, bigger than negative 1 or smaller than negative 1? Bigger. So this is positive. So positive times positive, positive. So this is positive. And what you're looking for? We are looking for positive y or 0y. So we accept both of them. So if this is positive, what's the next interval? Negative. Then what's the next interval? Positive. And then negative. And then positive. See, through every x-intercept we have to cross. So if you start with something positive, you have to cross here. And then you have to cross through negative 1 because you add multiplicity. That means you have to come back to positive 1 to cross. So the negative positive 1, you have to cross to 3. And then there is no more x-intercept, so you keep going on and on and on, upward forever. Five to 6 to the 4. Here's the x to the 4. Oh, x to the 4. Oh, you split x to the 4 into two pieces, x squared and x squared. Huh? Can we use that? You can, but you have to do more work, right? You need to do the math. But here, I didn't do any math. I just observed the sign. You can use any one of those, the first one, second one, or even the factored form. The main idea is you have to look for y. What's the y value for the specific x value picked? Okay, so it's time to find our solution. What's the solution? negative infinity, -3. So this portion is positive, this portion is positive, this portion is positive. Negative infinity to -3 bracket, because we are including the -3. The next portion, and then parentheses. And with this, we are done with chapter 2. Chapter 1 and 2 will be in the exam. And for the question to study all the green questions. For example, here, see, all these things, they have green, A, B, C, D. I mean, A is out because it's not from the homework, it's from the homework. But look at B, C, D, all of these are final exam questions.
They give a fraction per function.
What do you mean?
Like, the fraction and find the domain.
Rational domain.
Yeah.
The domain is the denominator.
Do the rest.
Set each factor equals to 0, omit those x values from the number line. So it's similar to the inequality, but inequality you look for positive or negative y. In domain, you look for what numbers you can plug in the x values. Okay, so tonight study all the chapter 1 and 2, all the materials, and see if any topics is unclear to you. You want me to explain more, then I'm going to go over those tomorrow. And if you don't have any question, I'll keep continuing with chapter 3. We're going to start chapter 3 now. And I'm going to post chapter 3 notes after class. I mean, not right after class, but I have another class after this class. After that, I'm going to post chapter 3 notes. Chapter 3 notes. Okay. So any other question, guys? Any complaints so far? We're going too fast, right? Are you able to digest all the information in your brain? Nah. Are you doing the homework? So please do the homework as much as possible, honestly, because see here, we cannot do many examples. It's not done. We're going to start chapter 3. So you cannot leave now. So to practice all the materials you're learning, homework is the best option. So please do homework honestly, especially the questions I go over in class. Definitely do not cheat on them when you do the homework. Okay? So first step is you have to modify the function. Means factor cancel. Here we factor, but there is nothing to cancel. So you take the original denominator that equals to 0. Every x value gives you asymptote. But the question we did before that, it was like this. We could factor, we could cancel. So after the cancellation, we left with only one x value on the denominator. One vertical asymptote. But if you take the original one, the original function has two x on the denominator. Not both of them have vertical asymptote. Whatever you cancel, that's the whole, and whatever you cannot cancel, that's the vertical asymptote. Any other question? Okay, let's start chapter 3. I forgot what we have in chapter 3. Let's see. Oh, exponential and log. I have a quiz. Let me give them back. And from chapter 3, there is only 5 sections. Well, but exponential and log actually a fun section, a fun chapter. Next section. Isabella. Adelia. Gonna she had okay. The exponential function and the polynomial function, they're completely different. They're completely different in format-wise, not graph-wise, format-wise. How they are different? All this time, all the polynomials we worked with, we had base x and our power was a number. But for exponential, it's the opposite. The base is a number and our power is a variable. So the format for exponential is a base number to the power x, and we multiply that with some type of leading coefficient a. So y equals a times b of x. And instead of y, we do f of x because exponential function is a function. So remember, when you want others to know whether you're working with a function or not, instead of y, we use f of x. So that's why it's f of x here, which is a function. Now, in this function, there's a condition. The base, it has to be, it cannot be 1, and it has to be positive. You can have a negative, that means if a is a negative number. So b itself is positive, cannot be 0, because 0 cannot be seen. And then we have a special type of base, it's called e. It's a number which value is 2.71, blah, 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 blah. Last thing you're going to do is evaluate the exponential function. Just like normal function, you substitute x with a given number and then simplify. Simple. So let's say we have an exponential function, 5 to the x. Actually, let me make it interesting. Let's say we have 2. No, that's not what I'm looking for. 2 times. Why is my right arrow? Okay. So let's say we have a function, exponential function, 2 times 5 to the x. So 2 is our leading coefficient and 5 is the base. Now, what is our base? Oh, I already told you. Oh, man. What is our base? Base. Our function is 2 times 5 to the x. 5 is our base. Now, your x value is -2. So we write 2 times 5 to the -2. So what is 5 to the -2? What does negative power mean, Kimberly? Divide. So it's 1 over 5 to the +2. That means we have 2 times 20, 2 divided by 25. And you have no idea what is 2 divided by 25. Leave it alone. So if you forgot your exponent rule, let me refresh your memory. If you have, let's say, a to the -1, it means 1 over a. If you have, let's say, b to the -2, it means 1 over b squared. So every negative power turns into a fraction, and then the power goes in the denominator with your base. Okay, now next one is 0. We have 2 times 5 to the 0, because 5 to the 0 is 1. The exponent rule says anything non-zero base, if you have the power 0, the answer is 1. So the answer is 2 here. And now f of 2. So 2 times 5 to the +2. And what is 5 to the +2 power? 25. And what is 2 times 25? 50. So if you observe, the y values are going too fast. They're increasing too fast. For -2, we have a fraction. For 0, it turns into 2. For only two numbers from 0, it's suddenly 50. So exponential function, they grow really, really fast. That's why we use the expression something is growing exponentially. For example, coronavirus, it spreaded exponentially. What does that mean? It means it spreaded so fast in just few amount of time. The rate of spreading was really, really high. So since it spread really high, so the graph of the exponential is something like growing upward really fast. And without any transformation or anything, the y-intercept is always y equals 1. Yeah, y equals 1. So every exponential graph, point x is 0, it goes to the y value 1 without any transformation. So this one has a transformation, scaling. We scaled 5 to the x twice. So that's why if it did not have these two, 5 to the 0 is 1. So without 2, the normal exponential graph 5 to the x, it has y value, y-intercept 1, point x is 0. So if your base is a whole number, it grows fast. But if the base is a fraction, it drops fast. It goes down fast. So fraction gives us a decreasing exponential function. Whole number base gives us increasing exponential function. And every exponential function, they have some type of asymptote. It's a vertical asymptote. Sorry, not vertical asymptote. Horizontal asymptote means there is a line they cannot cross. For example, without transformation, this is the line that we cannot cross. Y equals 0. With the transformation, the horizontal asymptote will be the up-down shifting. If you move upward, that upward movement is a horizontal asymptote. If you move downward, the downward movement will be your vertical asymptote. For example, if we have y equals, let's say 2 to the x plus 1, this plus 1 is a horizontal asymptote. Y equals 1. Let's see if we have y equals 2 to the x minus 5. This minus 5 is horizontal asymptote. Y equals minus 5. So it's a line that it cannot cross. The exponential graph cannot cross the horizontal asymptote. For a rational function, horizontal asymptote is like fence, it's weak. But for exponential function, the asymptote is like brick wall. They cannot cross the brick wall. They cannot cross the asymptote. Horizontal asymptote. Go back. And then the transformation is same, what we did for parabola or other functions. Say it again. Oh, plus 1 is outside. So 2 to the x and then plus 1. And this is minus 5. So we have exponential function and then a number. Means you're moving upward or downward. That upward or downward is our horizontal asymptote. So the transformation, we have 1, 2, 3, 4, 5 types of transformation. No, we have 5. So reflection, we have 2 types of reflection. Reflection about the x-axis or reflection about the y-axis. If you have a number in the front of your exponential function, it's reflection about x-axis. For example, y to the 2x would be this graph, but y to the negative 2x, 2 to the x will be a reflection of this graph, so it goes to the -1. We have a negative in front, so it's reflect about x-axis. But if you have a negative inside the function in front of x, that's your y reflection. So y equals 2 to the negative x. Remember, negative means it's a fraction. So now the base 2 actually a fraction 1/2. So that's why it becomes the reflection this way. So if you have a negative on the power, it's a decreasing function. If you have negative in front of the function, it's a reflection about x-axis. And then you have the function and the number, you go up, for example, the 2x plus 1. If this is normal 2x plus 1, then this one will be 2 to the x plus 1. You shift that 2 to the x into 2 to the x 1 unit up. And then for -5, if this is the normal 2 to the x, you are shifting this y-intercept 1 unit, 2 unit, 3 unit, 4 unit, 5 unit down, and you are drawing 1, 2, 3, 1, 2, 3, 4, 5, and you're drawing your graph here. And this should be asymptote. So you're taking the entire graph moving upward or downward if you have a number after your exponential function. And if you have a number inside the exponential function, means next to the x on the power, it's left, right, opposite direction. So you have +1, x plus 1 on the power, it means you are moving 1 unit to the left. If you have x minus 1 on the power, you are moving on the right 1 unit. So 1, 2, 3, 4, 4 types of transformation here. And there's a scaling. Oh, we're skipping scaling. So never mind about the scaling. Okay, let's do some transformation. We have 2 to the x and then -1. So what does this -1 mean? Down 1. And you also have your horizontal asymptote. What is your horizontal asymptote? -1. Because you shifted down, so it's -1. So let me draw the original one and the shifted one. The original one goes through here, 2 to the x, y value 1. Now we have an asymptote at -1. And we are shifting this y-intercept 1 unit down, so at the origin. So you're drawing this graph. 2 to the x minus 1. You're taking the original graph and you shifted 1 unit down. So -1 is a line you cannot cross. How about the next one? Up 1. So what is your horizontal asymptote? Y equals 1. So if this is your normal 2 to the x, you are shifting this x 1 unit up. So this is your graph. And now this line y equals 1 is the thing you cannot cross. So 2 to the x plus 1. Now the bottom one is same, but what's the difference? Oh, come on. What's the difference this time? Let's see. So we are still going down. Down 1. So horizontal asymptote is y equals -1. When the base is a fraction, what's the shape? Decreasing. It doesn't go wider, doesn't go narrower. It just opposite. The normal, the whole number goes upward, the fraction goes downward. So now we have a downward graph. So normal downward graph will be this one. 1/2 to the power x. That's the normal one.
Think that possible, or you see how the way you're drawing it is like starting or beginning at -1. It's not possible. Oh, it could be if it's 2%.
Yeah, if your x itself is negative. So we are starting with the left side and we are going down when you're walking to the right side. That's the normal half of x. Sorry, half to the power x. And we are shifting this one unit down. That means at the origin. And we have a y-intercept, sorry, horizontal asymptote, y equals -1. So this is 1/2 to the x minus 1. The left side is going up, the right side is going down, or whatever. Not down, like closer to y equals 1 line. Well, let me skip the other one. We have already idea. Let's do left right. We have +1 on the power next to the x. So which direction? Plus should go on the right, but it doesn't. It goes to the left. So we have left one. And the base E, you can ignore, it's just a number like 2. So left one. So let me draw this way. The normal E to the graph, E to the x is an increasing graph. And now we are taking this y-intercept and moving 1 unit to the left here, and we are drawing the same graph. Now, what is our new y-intercept? 2 point something. We don't care. The thing is, the old y-intercept, where it's moving. So e to the x plus 1. And then let me do the other one on the same plane. We have -1. Which direction? It's 1 next to the x, so it's supposed to be left, right. Anything next to the x on the exponential is left, right. And if you have a single plus minus, it's up, down. So we are taking this y-intercept and we are shifting 1 unit to the right, and we are drawing the same graph here. E to the x minus 1. What's the y-intercept, or what's the horizontal asymptote for both of them? Y equals what? Y equals 1, we have a point here. Y equals 0. If you don't have an up or down shifting, it's a 0 line. Y equals 0. So this one is y equals 0. This one is y equals 0. There is no up down movement. And now the last one. I hope the last one. We have a negative, so actually I should do it twice. But never mind, I'll do it once. The normal graph without any transformation goes to the y value 1. We have a negative in the front, so what type of reflection? X-axis. Reflect about x-axis. So our mirror is this one. If you reflect through the x-axis mirror, this point y equals 1 goes to y equals -1. And you have the same graph. 2 to the negative, 2 to the x. And then here we have a negative on the power. So what type of reflection? Y-axis. So this time our mirror is this. So if you reflect about the Y mirror, this side goes up and this side goes down. So whatever you have on the left of the mirror should be on the right of the mirror. Whatever you have on the right of the mirror should be on the left of the mirror. So it becomes a decreasing function. This is 2 to the -x. 2 to the -x. Any question on the transformation? So in a homework, you have a lot of questions on transformation. And luckily, you didn't have to draw anything. You just have to identify the transformation. Which transformation represents which equation. Oh man, I don't want to do all these things. Let's do one of these with all three transformation. I mean, here is only 2. Let's do this one. It has all 3 transformation. So negative in the front, which direction? Negative in the front. Reflection, x-axis. Reflect, x-axis. We have +2 next to the x on the power. Left. And then -3, down 3. Now, since we went down, we know horizontal asymptote. What's the horizontal asymptote? Y equals -3. Now let's draw. -1, -2, -3. This is the line that you cannot cross. This is our wall. Oh man, I should draw a little bit up. There is a reflection. So -1, -2, -3 is the line that we're not going to cross. Let's start with the first original one. This is our e to the x without any transformation. Now, if you reflect this e to the x about x-axis, this +1 goes to where? This +1 y value, it becomes -1 y value. Now, that -1, we are moving 2 left, 3 down. So 1 left, 2 left, 1 down, 2 down, 3 down. It goes 3 down here. So this point goes 1 left, 2 left, and then 1 down, 2 down, 3 down. So this is this point y-intercept becomes that number, and we have an upside down. We are crossing the y-axis, but through which number? I don't know. Negative e to the x plus 2 minus 3. And this is our y equals negative 3 horizontal asymptote. So an increasing exponential graph turns into decreasing exponential graph, and it shifted to the left and then shifted down. Or you can do down 3, left 2. You can go 3 direction, whichever you want. You can go 1 down, 2 down. No, we're starting here. So 1 down, 2 down, 3 down, and then 1 left, 2 left. Any question? One last one. It looks similar, but a little bit different. We have a negative on the power. Y-axis reflection. Reflect y-axis. And then we have a +1 alone. Sorry, +4 alone. Which direction? 4 up. Since we went up, so we know horizontal asymptote. What is the horizontal asymptote? Y equals 4, because we went 4. So let's draw 4 up and this. So the original graph is this, e to the x. First, we reflected about y-axis. So this is our mirror. This becomes our reflection, e to the negative x. Now that reflection, we took this y-intercept and we went 1 up, 2 up, 3 up, 4 up here. And then this is the graph. So this is 1, 2, 3, 4. 4 is the line that you cannot cross. So a new y-intercept turns into 5. It's actually going down, not going up. It's this way. Any question? So all this is too much, right? Good news in the exam, you don't have to draw, but you have to identify them. For example, here, just few more questions, and then you're going to learn. We are given a graph. What could be the equation of this graph? B. How do you know? We are moving 1 down. So the original graph was this. You can see clearly this y-intercept went 1 unit down. So definitely it's exponential going down 1 unit, so it's B. How about this one? We have 2 times e to the negative x. You can ignore the 2. It's making wider or narrower. But e to the negative x. Which one is e to the negative x? So negative x on the top. Which type of reflection? Y-axis. So this is the normal graph. If this is your reflection, which one makes sense? B. How do you know it's B? A is the original without times 2, but B is the original times 2. So B has y-intercept at 2. Definitely these two. This is not correct, this is not correct, because the y mirror is wrong for the bottom two. Okay, so tomorrow we are going to continue doing chapter 3. And if you have any question from chapter 2 or chapter 1, please bring them tomorrow. I will do more chapter 1 and 2 if you bring any question. Fraction, so 1/2, let's see. Yeah, fraction makes it wider. The coefficient. So for the defense, it's hard to study all the main questions. Should we prioritize the homework? The homework, I mean, all the green question, but I'm not going to give the exact same question. Yeah. I'm going to give similar one. So how can you practice? Like, how do you know which of them understood or not? So homework tells you. Have you seen them? Yeah, I know. Message, can you see? Unless I go inside the website, so which I usually don't. So I shouldn't do it. But you can try, like in case if I go in to see who is doing the homework, I'll see them. Ignore mine because I ask you and then I figure it out. No. Usually they don't send me any notification when student email me. So I really have to go inside the website to see what's happening inside the website. Thank you.
The exam is on Thursday.
Thursday, day after tomorrow.
My sister's watching him today and tomorrow, but she has regions on Thursday. My parents have work on Thursday, but they're gonna go on Friday instead. I can get a note.
Bye. Can you take it tomorrow then?
In class?
No, after class.
Okay.
So after class tomorrow. Okay.
So I think I overheard. Do we email you to grant the extension?
Even the extension, you didn't have time.
Sorry.
You don't have time for extension. Chapter 2 homework due is Monday, next Monday.
Right.
Chapter 3, 4 homework is chapter 3 is next Monday. 4 is next Monday. So
No,
why you have time?
No, I'm talking about from chapter 1.
I know. I'm asking if you keep doing chapter 1, when are you going to do chapter 2?
Well, just to get
And then you have
for the
chapter 3.
Well, I had some events, but
Uh-huh.
so are we allowed to get the extension? No. For chapter 1. Chapter 2 is like 5.
Okay, I'll do that. And if I forget by tonight, remind me tomorrow.
Okay.
I mean, send me an email. Okay.
Okay.
Email is better. I did not. Why did you email me?
I was asking for an extension.
Why did you email me? In my Gmail? In my Baruch mail? Regular Gmail? Yes. You sure you emailed me?
Yeah, but it was kind of late because I had an emergency.
Oh, I didn't check the email today yet. Uh-huh. Oh man.
Yeah.
Who
Okay.
died?
It's like my uncle.
Oh. Okay. No problem.
2 deaths.
Yeah.
Oh man.
So could you able to grant just like I finished the rest like 1.2.
I'll open them.
I just have
Yeah.
the last 2 in chapter 1. Everything else is fine.
The last 2, and you also the last 2?
I finished start from the bottom, so I just have to.
Oh, you start from the bottom?
Yeah, like I thought the other ones were gonna be hard, so I started from the bottom.
Oh,
Yeah.
yeah, no, like normally I would have had more time to do that. It's just like going with girls and
Yeah.
just away from like the hours I'm.
Okay, I'll open them.
Thank you.
No problem.
I'll,
But make sure to study for the exam.
Yeah, I will. But I just didn't have the time to finish the assignments yesterday. Thank you though.
No problem.
Oh, and I know you also mentioned how.
Oh, I missed a record.
Oh,